Hi, all. It's a nice day out. I'm out on the patio watching the Pittsburgh Pirates game. Hopefully, they'll win today. But I wanted to talk about a couple things, particularly ringing in amplifiers, feedback, and also wanted to mention a output transformer change that I did in one of my amplifiers. The Audionote Kit 4 clone that I had built some time ago, I was using Edgar output transformers. Or I replaced them with some Habor output transformers after I was impressed with the last set I bought. And boy, what a difference. The lows have more punch, the highs are more clear and defined. So the Habor transformers, they're hard to beat, especially for the cost. They're excellent performers. Now, the Transcendar transformers, they were excellent performers too, but unfortunately, the website has been down for a while. I don't know how you go about ordering other than maybe finding a phone number and see if they're still making them, the fellow that's doing that. But the Habors in the Kit 4 are 20-watt output transformers. And also, I finally got around to installing the tube cages that I had purchased several years ago for that Kit 4 amplifier. Here's a couple photos. Here's the photos of the top without and with the transformer cages. So that project is nice and it sounds great. But let's get on to talk about ringing. What is ringing? How do we test for it? And why is it undesirable? And what can we do about it in a vacuum tube amplifier? Well, ringing is the appearance of sharp transients or oscillations in the signal. It's what can cause damage to sensitive tweeters, the high frequencies. And actually, ringing causes waste, energy waste, and also heating up of components. Now, in the examples that I have seen in vacuum tube amplifiers, the ringing has been what is called post ringing. And just because there is ringing present in an amplifier doesn't necessarily mean it will affect the actual audio quality of the sound that we hear, unless it's in within the range of our hearing. Of course, everyone is different. Some people can hear a lot of higher frequencies and detail than others, but that's a personal preference. And out of all my amplifier builds, I've built over the past 10 years, I've built 6 vacuum tube amplifiers and 2 vacuum tube tone controls. Actually, the Kit 4 was after I replaced the transformers with the Habors was the only one that I didn't have to address any ringing issues with, which was really surprising. Whether it's the circuit and the transformers, I don't know. Now, an easy way to test for ringing is the use of a signal generator and an oscilloscope, two basic items, using square waves at 1000 hertz and 10,000 hertz. Why use square wave signals? While square wave signals can reveal a lot about a signal with just a visual analysis, so it's pretty simple to do. And you don't need expensive equipment. What I have is an oscilloscope, a model, as I have it written down here. I can't remember things at times. An SDS 1102. It's a 2-channel digital storage oscilloscope. It has enough features for me, and you can pick one up for $200 to $250. The signal generator that I use is a FY6900. It's a DDS function arbitrary waveform generator, and you can purchase that for about $135. And it's a two-channel generator, and it works great for me. So you don't have to dish out a whole lot of money. And as I put together vacuum tube circuits over the years, I've learned a few simple things to improve the situation. One is to adjust the amplifier feedback with the proper feedback components that work with the output transformers that you're using, and also high frequency compensation in the circuit to help quash some of the high frequency if you have issues. As I mentioned in some of the previous videos that I did, I've learned a lot from the Fun with Tubes user group. And also Max, who runs the Fun with Tube website, he has a treasure trove of information up on the website about tube amplifiers and all kind of things. You know, Max, he's a good old guy. He's a retired physics professor. And if you are interested in learning electronics, he has a nice book available for download that he actually had written to teach electronics to his students in college. But before I show you a quick clip of what ringing is and a little example on squashing it, I wanted to mention about the high frequency snubbers. Now, I can show you in this video this quick clip of the video that I added on here that it's adjusting the feedback and how that can help. But also, sometimes you may need high frequency snubbers in the circuit. And also in the description, there is a link to a PDF file from Mr. Tim Smith. Now, Tim is a great engineer. Now, me, I'm not so great, but I do have some electronics background, and I've been a maintenance electrician. I'm retired now for 45 years, so I always was interested in electronics all the way since I was a boy and picked up a lot of things. But the engineering part, I'm not so great at, but the repair part, I was always good at repairing things. And one of the reasons why is if you learn about the components in a circuit and you know what to expect from them, it's a lot easier to troubleshoot what's going on. If you know what they should be doing, if you know what voltages should be present and what's going on in a circuit, you'll go a long way. I always had trouble with math when I was a kid, had trouble with math in college, and I got into some of the trig, and boy, I was kind of lost in college. But I had a teacher once at a electronics school, an old Navy guy, and he was great. And I always had trouble with working with the math, with all the X and Y's and Z's and all that. But working with this teacher, plugging in real values, looking at a real circuit, it just something just snapped and it was completely clear, all the math. So it does depend on the teacher and what you're doing and how it's applied, I guess. But anyway, this PDF file that Mr. Tim Smith wrote is called the Empirical Implementation of Global Negative Feedback. Now, Tim has built a lot of vacuum tube amplifiers. I think he mentioned to me one time it's been over 50 over the years. So he is a good engineer and has engineered some good circuits, and he kind of sticks with that. Once you find something that works, hey, stick with it. And I think all of them were point-to-point wiring. Now, I've used PC boards and I've used turret boards in some of my builds, which worked out okay for me. Now, Tim describes in detail how to properly set the vacuum tube amplifier feedback. So it's a really good article. You can download it. I'll put it in linked in the description. And also how to figure out the values for the snubbers and where to add them in the circuit. And some of this information is in the Radiotron Designer's Handbook, 4th edition. And snubbers across each half of the can be put across each half of the primary, or can be connected plate to plate on the output transformers, as in these two examples of my ST35 clone and my ST70 clone, where I used both ways to put some snubbers on the output transformer. And also in the preamp circuit, as you read on in Tim's article, you can see where you can also do the math and figure out what you might need on the preamp tubes to help stop any high frequency, because you don't want to destroy your expensive tweeters. That's for darn sure. But anyway, here's an example of my KT88 single-ended amplifier. I'm showing the results with some ringing with changes in the feedback capacitor value. So this is the inside of the single-ended KT88 amplifier. But let me show you these waveforms. Now I already have the resistor value set on this, and I've disconnected the capacitor, but I just wanted to show you what it looks like. Let's get up here to the scope. Now, this is at 1000 hertz, and you can see the ringing at the top here. Let's see if I can get that scale a little bigger. You can see that ringing up there on the top. Now let's put in a 5-volt signal in. Right now I'm reading about, there it is, volts peak to peak. That's about 5 watts output. But you can see that ringing. Now that's at 1000 hertz. But let's switch it over to 10,000 hertz here. Whoops. Now you can see how bad that looks. a lot of distortion and ringing in that waveform, which is not good. Now I'm going to show you the difference. I'm going to start out with a this is a, I think this is a 500 picofarad capacitor, and I'll show you the difference of what that can do to quash the ringing. So that's 500. You see that ringing. It takes it down some. Well, let's see what a now let's look what that does at 1000 hertz. Now that's at 1000. You see that ringing in there. You see 500 picofarads, what that does. I have to make an adjustable, as I said, I'm going to make an adjustable test setup like Timmy did, but I haven't done that yet. It's on my list of to-do things. But let's change that to an 800 picofarad. Even more. You see that it's taking it down some. Let's switch that over to 10,000. You see the difference there. Now let's parallel the 800 and the 500, which will give us 1200 or 1.2 nanofarads. And let's look at what that does. Well, that takes it down pretty good. That's not too bad. That's at 10,000. Let's look at it at 1,000 hertz. Kind of squares that square wave off there. So what I ended up doing here is what I had in stock. I have a 1.7 nanofarad, and that's what I'm going to use. I'll show you. It's close. See the difference? Pretty much wipes out all that ringing. Again, that's at 1,000 hertz. And let's switch that up to 10,000 here. Whoop, change the scale up. You can see that rounds that off pretty good. See, it gets rid of all that ringing in there. So that's it. If you have any questions, suggestions, comments, please leave them. As I said, I'm not an engineer and I miss a lot, but I've been learning over the years. I forgot a lot of electronics in my past. As you get older and you don't put it to use, you do forget things, but I enjoy working with tube amplifiers. I've built some solid state amplifiers, but I just enjoy working with the old tubes. I think there's a mystery there, and it's fun to do. Well, that's why Max named his website "Fun with Tubes." So that's enough for today, and I'll get back to the ball game. Have a good day.